Snowboarding is a popular sport with over 5 million followers worldwide. And one snowboarder's passion has inspired the subject of her engineering research.
Well, I really love snowboarding, and so I decided to combine my love of snowboarding with my engineering doctorate so I could get to come out to the mountains all the time. I'm looking at all the elements that make a snowboard what it is, so the way it's going to turn on the slopes, the materials we need, what shape it needs to be, and the construction, so how we're going to bond that board together.
Today, Lisa wants to look at how a snowboard vibrates on the snow so that she can create a smoother ride.
What I've got here is a snowboard rigged up with 2 accelerometers, one on the nose, one on the tail. And what they're going to do is measure the vertical accelerations of the board as Cody's riding it. So the up and down motion as we're performing turns.
Cody Hirons, a competitive snowboarder, is testing the boards.
What I want you to do is press the trigger, and I'll meet you down at the bottom in about 10 seconds after you've been recording the data.
Okay, cool.
Good luck.
The information gathered is stored in a data recorder in Cody's rucksack. Back in the UK, Lisa feeds the information into a computer system she's had to design herself.
I write the mathematical code from the ground up, which I can then use to analyse the way the snowboard behaves. For example, the strength, the stiffnesses, how much of a beating can it withstand on the slopes.
Lisa needs to understand how the complex composite structure of a snowboard affects the way it performs.
OK, so I've got a cut-through snowboard here. Snowboard's what we call a composite material, so it's made of more than one material, lots of different layers. First off, we've got this running base here. That's made of a polyethylene material. Just above there is the glass fibre layer, so that's what gives the snowboard its stiffness and its strength, really. On top of that, we've got the wood core, and then a second glass fibre layer which runs along the top. And then finally, on the top, we've got our graphic, which protects the glass fibre. Composites were designed for sort of really high-end engineering applications. They are very strong materials. I'm doing this research to see how far we can push it in snow sports.
Lisa is now experimenting with the glass fibre layers.
The glass fibre is going to affect the stiffness of the snowboard, how much it's going to bend along its length, and also how much the rider can twist it between their feet. Testing snowboards in the virtual environment means that I can test hundreds of different material layups and lots of different arrangements, and I don't have to build all the prototypes, which is not only time-consuming but very expensive.
Having decided on what prototype she's going to build, it's back out to the slopes to try it for real in the half-pipe.
This prototype is one of 3, and they've been made with 3 different grades of fiberglass density. So this prototype's been designed with slightly denser glass fibre layers, so it should be a bit stiffer, hopefully hold better on the landings. The problem when you are designing a board is I can spend absolutely hours in the lab designing what I believe is the perfect snowboard. If I give it to one of the riders who then takes it out and says, "No, Lisa, you've not got it right," then I haven't got it right. I can't argue with that.
It was really good. It's really nice and stiff. Very easy to control your speed in the pipe. And it's real good. It's good fun.
When Lisa's happy with the design of a board, she can take it on to the next stage. She's now set up her own company to make the boards and is already manufacturing up to 1,000 a year.
My ambition for the future is to have a rider win a medal at the Olympics in 2014 on one of my boards.